So yeah, good evening. So let's start our today's class. So I hope my screen is visible. So hello everyone, this is lecture 9 on computer networks, and in this lecture we are going to start vulnerable time of ALOHA. Okay, so we have studied ALOHA technique. Okay, and in ALOHA we have completed few numericals. Okay, and basic introduction we have completed, and now we are going to start vulnerable time of ALOHA. Okay, vulnerable time. Okay, this is very important. Many times question have been asked. So what do you mean by vulnerable time? Vulnerable time is range of time in which collision can take place. Range of time in which collision can take place. Okay, so range of time in which collision can take place, that is known as vulnerable time. So in which range collision can take place, okay, that is vulnerable time. Vulnerable, I think you already know, this is term used for say I am very vulnerable to diseases and so on like that. So vulnerable is, I think you already know, this is an English term. Okay, so it is the range of time in which, so it is ALOHA is vulnerable to what? Collisions. Okay, because any station can send data at any time. Okay, whenever station want to send data, it can send. So it's vulnerable to collision. So we will say that range of time in which collision can take place, that is your vulnerable time. So for example, let me give you a small example, you will get more clarity. So there are two stations, station 1, 2 and 3. Okay, and let us suppose transmission time is 2 seconds. Roughly I'm taking transmission time is 2 seconds. Okay, and we are assuming speed of light is 3 into 10 to the power 8 meter per second. So it is very high. So these stations are very close to each other. So I will assume negligible amount of time. Okay, so the moment S1 started sending bit, so first bit, it will immediately reach to S2, it will immediately reach to S3. So directly indirectly what I want to say is, since speed is very high and stations are very closely they are very close to each other, so I'm assuming TP is equal to 0, approximately 0. Okay, so speed of light, if you is 3 into 10 to the power 8 meter per second. If I am see, if stations are about say 0.5 meter apart or 1 meter apart, so it will take negligible amount of time. That's why I'm taking propagation time to be 0. That means the bit is started from S1, it will immediately reach S2, it will immediately reach S3. This is my assumption. Now assume, since transmission time is 2 seconds and S2 wants to send at 4 a.m. or you can say 4 second or fourth second. Okay, S2 want to send data at fourth second. Now you can imagine that till 4 to 6 S2 will send the data. 4 to 6. Okay, now if S1 wants to send data at say just 2.1 also, or you can say 2.00001 also, I will it is guaranteed that when S2 start, okay, or when S1 you can say stop the transmission, it will stop at 4.001 and S2 starting at 4, so collision will occur. Are you getting it? So S1 will start at 2.001 and it will end its transmission at 4.001 second. Okay, and S2 start at 4 second. So obviously collision will occur, na? So more precisely I will say tail of S1 packet, tail of S1 and head of S2 will collide. Are you getting it? Tail of S1 and head of S2 will collide. Okay, tail means end. So end of packet, it is just it is just ending its transmission and S2 is just starting its transmission. So obviously collision will occur. Similarly, if I say S3 start say at 5.999 second. Okay, even then I will say S2 is just going to complete and S3 has just started. So obviously tail of S2 and head of S3 will collide. Okay, so in this scenario, tail of S2 packet, okay, tail of S1 packet, tail of S1 packet and head of S2 packet will collide. Now S1 and S2 are not colliding, they are stations. Okay, tail of S2 packet and head of S3 packet collide. Okay, so there are chances of collision. So what is the range of time in which collision can take place? So if S2 want to start at transmission at 4th second, so no station can send data just after 2 second, and no station can send data just before 6 second. Can you are you getting it? So if S2 wants to send data, let me use another color. What is the bottom line? If S2 wants to send data at 4th second, then no other station should start just after 2 or just before 6. Okay, because then otherwise collision will occur. So what is range of time in which collision can take place? Range of time in which collision can take place is 2 to 6, that is 4 second. 2 to 6, that is 4 second. Now what you have taken transmission time to be 2 second and vulnerable time is coming to be 4 second. So directly indirectly this means that vulnerable time is nothing but twice the transmission time. This is very important formula. Many times question have been asked in GATE. That's why I have spent 4 to 5 minutes in explaining this basic concept only. So you should remember this: vulnerable time is equal to twice the transmission time in case of pure ALOHA. Vulnerable time is equal to twice the transmission time in pure ALOHA. Okay. So we have to study for every protocol. In slotted ALOHA it will be different. In CSMA it will be different. So you have to remember vulnerable time. This is a generic term which is used in every protocol. So you should know this. And I have introduced this vulnerable time in ALOHA itself. Okay. Yeah. So you can take snapshot of this and I will jump to the next slide. If you have any doubt, you can ask me.
So second point, what have you started with?
Okay. Range of time in which collision can take place is 2 to 6, that is 4 second.
Done, sir.
Okay, so please take snapshot.
Yes, sir. Yes.
Okay. Yes, so vulnerable time is completed. So now we will do a question. The question is: a pure ALOHA network transmit 200 bit frame. A pure ALOHA network transmit 200 bit frames on a shared channel of 200 kbps. Okay, what is the vulnerable time? Shortly I'm writing what is the vulnerable time. So a pure ALOHA network transmit 200 bit frame on a shared channel of 200 kbps. So vulnerable time of pure ALOHA is 2 multiplied by transmission time. So 2 multiplied by transmission time formula is message size upon bandwidth. So 2 into message size of frame size, that is 200 bit, and it is 200 kbps. So 200 into 10 power 3. So it comes out to be 2 millisecond. Please let me know if anybody is facing any difficulty.
Clear, sir.
Okay, take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next question, or rather we are now jumping to the next topic in ALOHA, that is throughput of ALOHA. Throughput of ALOHA. So what is the throughput? Throughput is S represented by S. S is equal to G into e ka power minus 2G. Okay, and I'm not going into detail that how we have derived this formula. It need a lot of mathematics. It is not needed for GATE. You should know the formula for throughput of ALOHA, that is G into e ka power minus 2G. Now what is this G? Okay, what is this G? And E you already know, 2.7. 2.7 something. Okay, exponent e. And G is what? Number of frames generated by network in one transmission time. Number of frames generated by network in one transmission time. Okay, in one transmission time, how many frames are generated by the network? That is represented by G. Okay, so throughput is S is equal to G into e ka power minus 2G. So let me solve one or two numericals so that you get more clarity. Take snapshot. I will jump to the next slide.
Done, sir.
Okay, so the question is, if frame size is, let me write it shortly. Frame size is given to us as 200 bits. Bandwidth is given as 200 kbps. Okay, and pure aloha network is given. They are saying it is pure aloha network, or it hardly matters. They say aloha or pure aloha, one and the same thing. Okay, if question is about slotted aloha, they will properly mention the word slotted aloha. Okay, you cannot assume that it is slotted aloha. By default, aloha means pure aloha only, or original aloha. Okay, pure aloha, or you can say original aloha, or directly say aloha, one and the same thing. Okay, if question is about slotted aloha, they will properly mention it. Okay, so frame size is given as 200 bits, bandwidth is given as 200 kbps, and now I am asking three questions. First is, 1000 frames are generated by network. 1000 frames are generated by network in 1 second. Next, let me copy it out. 500 frames, and C option is 250 frames. Okay, now they are asking about what is the throughput. Okay, so a frame size is given as 200 bits, bandwidth is 200 kbps, pure aloha, original aloha, or slot or aloha, one and the same thing, it is given. And they are saying what is the throughput if 1000 frames are generated by network in 1 second, or 500, and so on. Okay, so now what I will say, see what is G here. See, what is the
Sir,
definition of G? What I have given you, number of frames generated by network in one transmission time. Okay. So now what question is saying, 1000 frames are generated by network in 1 second. So it hardly matters. I am not concerned with 1 second. I am concerned with one transmission time. Yeah. So please let us find that thing first. So what is the transmission time here? And let me write it. What is the throughput they are asking? Okay. Throughput they are asking. This is the question. So for A part I am doing. So first question, first is what is the throughput? Throughput is S is equal to G into e ka power minus 2G. So you just need to calculate G. Game is over. So now how we will calculate G? That's why I have given you this question. So G is number of frames generated by network in one transmission time. But here 1 second is given. So first let us find transmission time. Transmission time is message size upon bandwidth, or frame size upon bandwidth. Frame size is 200, bandwidth is 200 kbps. So it comes out to be 1 millisecond. Okay. So let me write it here. So it comes out to be 1 millisecond. Okay, so now what they are saying is, in 1 second 1000 frames are generated. In 1 millisecond, how many frames will be generated? Only one. Okay, so in 1 second 1000 frames are generated. In 1 millisecond, how many frames will be generated? 1000 into 10 power minus 3. Now 1 millisecond is 10 power minus 3. So it comes out to be 1. So directly indirectly this means G is equal to 1. G is 1. So now game is over. So what is the throughput? 1 into e ka power minus 2 into 1. So it comes out to be 1 upon e square. Okay, so if they that is our throughput. Okay, 1 upon e square, or you can calculate its value and so on. So if you multiply it by say 100, you will get it as 13.5%. You can do it yourself. It's your homework. Okay, so basically we are calling it as throughput, but actually we are calculating efficiency. Okay, because throughput means efficiency multiplied by bandwidth. This is the efficiency 13.5% multiplied by bandwidth. You will get the throughput. Okay, so here this formula is actually for efficiency. Okay, throughput of ALOHA, actually we should call it as efficiency, but generally your textbook, frozen books and all, they are saying it as throughput only, so we are considering it as throughput, no need to worry. But actually throughput is nothing but throughput is efficiency multiplied by bandwidth. So this efficiency we are calculating here. Okay, so roughly they will say that 13.5% of your bandwidth we are going to utilize. So that's why they are calling it just like a throughput kind of thing. Okay, throughput means actually how fast we can send data. So you will say that for if bandwidth is 200 kbps, then from 200 kbps we can utilize only 13.5% of it. Okay, yes, so throughput is coming to be 13.5%. So anyway, it entirely depends on in gate exam question what options they are giving and so on. So if throughput is given in kbps and so on, then you will multiply efficiency by bandwidth. If it is in percentage only, you can leave it here itself, no need to worry. Okay, so A option we have completed. Now B and C are left out. Let me do that on the next slide. Take snapshot.
Done, sir.
Okay, so B option was 500 frames are generated by the network in 1 second. Now, so here G was coming to be 1. If for 1000, for 500 it will be 1 by 2. Okay, if you have any doubt, I will say like this: in 1 second, 500 frames are generated. In 1 millisecond, how many frames will be generated? 500 into 10 to the power of -3, and it comes out to be 0.5. That is 1 by 2. Okay, so what will be your throughput? G into e ka power minus 2g. So G is coming to be 1 by 2. So 1 by 2 into e ka power minus 1. It comes out to be 1 by 2e. Okay, and if you multiply it by 100, percentage will be 18.4%. Okay, you can check that out yourself. It comes out to be 18.4%. Okay, next is 250 frames. So in 1 second, 250 frames are generated by the network. So in 1 millisecond, why I'm talking about 1 millisecond? 1 millisecond was the transmission time. That's why. See this, transmission time was coming to be 1 millisecond. That's why we are doing that thing. In 1 second, sorry, in 1 millisecond, 250 into 10 to the power -3, that is 0.25 frames will be generated in 1 millisecond. So what will be the throughput? S is equal to G into e ka power -2g. So 1 by 4 into e ka power -2 into 1 by 4. So 1 by 4 root e. Are you getting it? 1 by 4 root e into 100. Roughly you can calculate it. It comes out to be 15% approx. 15% roughly. Okay, you can check that out. Okay, so these are my examples. So maximum throughput is coming when this is 18.4%. You have to remember this figure. This question have been asked in gate. Take snapshot. I will jump to the next slide. I will explain you those things also. Take snapshot.
So the last answer is here 1 divided by 4e, isn't it?
Yeah, yeah. 1 by 4 e minus 2 into 1 by 4, na. So -2 and e to the power -1 by 2, na.
It's
E to the power
inverted.
-1 by 2 will be root e in down in denominator.
It will be 1 by 2, no, sir?
Yeah. So it will be 1 by 2. E to the power -1 by 2, na.
And the next you have written 1 by 4
Root e.
root
See
e, sir,
this.
right? Yeah,
E
sir.
power
Yes,
-1 by 2 is what?
1 by 2 is root, yes, square root, sir. Yes.
So it will be 1 upon e power 1 by 2. So it will be 1 by root e. Is it okay
Done,
now?
sir. Yeah, yes, sir.
So take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So we should know this fact that maximum throughput of pure ALOHA is approximately 18%. Maximum throughput of pure ALOHA is approximately 18%. And when it is coming to be 18%, when G is equal to 1 by 2. You should know these terms properly. Maximum throughput of pure ALOHA is approximately 18%, and it is coming when G is equal to 1 by 2. That is, half frame is generated by network in one transmission time. That is 1 by 2 frame, or you can say half frame. half frame is generated by network in one transmission time. Okay, that is the basic thing. They can ask that when pure ALOHA will have maximum throughput. MSQs are coming now, multi-select question, so they can ask this theoretical question. So when maximum throughput will come for pure ALOHA, when half frame is generated by the network in one transmission time. Okay, half frame is generated by network in one transmission time. Okay, so you can take snapshot. I will jump to the next slide and
Done.
we will solve another beautiful numerical on this concept only.
Done, sir.
Okay, so the question is, assuming there are n stations present in pure ALOHA network. Okay, so assume, okay, in place of writing entire numerical, I should write like this. So total number of stations in the network are n stations are there in the network. Okay, bandwidth is 56 kbps. Okay, and each station send frame of size 1000 byte. Frame size is 1000 bits. Let me simplify it. 1000 bit. Frame size is 1000 bit. Okay, and uh, each station is sending data at an average interval of 100 seconds. Each station is sending data at an interval of 100 seconds, and they are asking us to find maximum value of n. Find maximum value of n. So let us try to solve this question. Okay, yeah, so the basic thing is, many of you will say the bandwidth is 56 kbps, so we will consider this only. No, we will not consider it, because I have told you that throughput is 18%, so we will take its 18%. Okay, so throughput means, or you can say efficiency is 18%. Now 18% efficiency means what? For the bandwidth 56 kbps, you will not be able to utilize it completely. You will utilize only 18% of it. Okay, so first of all, what we should say, throughput is efficiency multiplied by bandwidth. Maximum, they are saying, na, find maximum value of n. For maximum value of n, you will take maximum throughput. Maximum throughput is coming to be 18%. So 18 upon 100 into 56 into 10 to the power 3, and roughly it comes out to be 10080 bps. Okay, you can calculate it. I'm not wasting time, so you can calculate it. 10080 bps will come out to be the throughput. Okay, yeah, and now they are asking, what they are asking, each station is sending data at an interval of 100 seconds. So directly and indirectly, each station is sending how many bits frame? 1000 bit frame at an average interval of 100 seconds. So bandwidth needed by each station will be what? Bandwidth needed by each station will be what? Needed by each station, that will be 1000 bits data it is sending at an average interval of 100 seconds. So divided by 100 seconds, it comes out to be 10 bits per second. So each station need only 10 bits per second bandwidth, and total bandwidth which is available is 56 kbps, but we are not considering 56 kbps, we are considering 18% of it, that is 10080 bps. So now each station need 10 bps bandwidth, and total bandwidth available to us is 10080. So how many stations can be connected? So n multiplied by 10, that will be equal to 10080. So n comes out to be 1008. This is my answer. Roughly 1000 stations you can connect to this network. Okay, are you getting it? So there are n stations in ALOHA, and they are saying bandwidth available is 56 kbps, frame size is 1000 bits, but each station is sending data at an average interval of 100 second only. Okay, so each station need only 10 bps bandwidth. Now since each station need only 10 bits per second bandwidth, so how many stations can be connected? Total available is 10080. So number of stations, maximum number of stations that can be connected is 1008. Okay, because 100 stations are there, each station need 10 bits per second bandwidth, so total bandwidth is 10080. I think you have got the point. Please let me know if anybody is facing any difficulty here.
Understood, sir.
Okay, so please take the snapshot. I will jump to the next slide now.
Done, sir.
Okay, so here we have completed ALOHA. Now we are going to start slotted ALOHA. Slotted ALOHA. So what do you mean by slotted ALOHA? Slotted ALOHA means here time is divided into slots, each of transmission time. Okay, please take the notes. It will be beneficial for you. In slotted ALOHA network, time is divided into slots. In slotted ALOHA network, time is divided into slots, each of transmission time. In slotted ALOHA network, time is divided into slots, each of transmission time. Each of transmission time. So even if station has data to send, even then it cannot send. So even if station has data to send, even then it cannot send. It cannot send. That is, it will wait for beginning of the slot. That is, it will wait for beginning of slot. So what I am saying in this point is, that is very easy. See this, if I am taking transmission time to be say 2 seconds. Okay, so time is divided into slots of transmission time. I have told you now, as the name says, slotted means time is divided into slots and each slot is of transmission time. Okay, so if I say transmission time is 2 seconds, so I have divided the time into slots. So I will say 0, 2, 4, 6, 8, 10 and so on, like this. So now if station want to send data at 5 second or 5th second, it will wait till beginning of the next slot, that is 6. So now it will send data at 6. Now if station want to send data at 6.001 also, even then it will wait till beginning of the next slot, that is 8. So if station want to send data at 5th second, it will send data at 6. Send data at 6. If station want to send data at 6.001, it will send data at 8th second. Are you getting it? That is the basic meaning of slotted ALOHA. A real life example also I have told you in the previous lecture. What I was saying is, so here we have a highway and here we have a service lane. You have a car and you want to put your car onto the highway. So what ALOHA is saying, you just blindly do it. Okay, whatever will be the result, you will have to bear it. You will blindly do it. Okay, the moment you think, you will do it. Slotted ALOHA is saying you will see the watch time. Okay, you are wearing a watch and in your watch you are seeing the time. Okay, and if at 4th second, if at 5th second you want to put your car onto the highway, you will wait till 6. Okay, at 6 you will put your car onto the highway and you have to bear the result, whatever may be the result. Okay, that is the basic meaning of slotted ALOHA. So time is divided into slots, each of transmission time, and let us suppose transmission time is 2 seconds, and so time is divided into slots like 0, 2, 4, 6, 8, 10 and so on. Okay, so every station will send data at beginning of the slot. So if station want to send data at 5th second, it will send data at 6. If station want to send data at 6.001, it will send data at 8 and so on. I think you have got the point. Okay, if station want to send data at say 8.9, it will send data at 10 seconds. So simple. That is the basic meaning of slotted ALOHA. So now from this only you may be able to guess. First of all, please let me know, is there any chances of collision here or there is no chance of collision? There are still chances of collision. There are chances. Yeah, please come again.
That's all. There is a chance, sir.
Yeah, why?
Because if data started, let's say 8.9, and even if the data started at 10 even, they collide.
No, at 8.9 one station tries to send data, but it will send at 10 second.
What
so
if they have one more which is started at 10 or before 10?
Yes, that was the point. Yes, good, that is the basic point. So 8.9 one station tries to send, it will send at 10. and if some want to send at 9.2, it will again send at 10. If somebody wants to at 9.5, it will again send at 10, and so on. So collision chances are there. Okay, so now I will tell you what is the vulnerable time. What should be the vulnerable time? Vulnerable time means range of time in which collision can take place. So clearly range is 6 to 8 na. If somebody tries to send at, so okay, so we are talking about 8 to 10. So I will say if somebody tries to send at 8.9, 9.2, 9.5, everybody will send at 10. So range is from 8 to 10. That is the vulnerable time. So vulnerable time for slotted ALOHA is transmission time. But for pure ALOHA, it was twice the transmission time. Okay, but here it is only transmission time. Why? Because in one transmission time only, all the stations which want to send data, they will send that. Okay, so range is transmission time only. So you can take the notes. Okay,
Yes.
please take the note. Here also collision can take place. Here also collision can take place. Here also collision can take place. For example, if transmission time is 2 seconds, and any station want to send data at 8.9, comma or 9.2 or 9.5, etc. Any station want to send data at 8.9 or 9.2 or 9.5, etc. Then all of them will send at 10th second. Then all of them will send data at 10th second, and hence collision will take place.
All of
And
them.
hence we will send data at 10th second.
Yes, sir.
All of them will send data at 10th second, and collision will take place. Next point. Vulnerable time for slotted ALOHA is transmission time. Vulnerable time for slotted ALOHA is transmission time. Write like this: vulnerable time is equal to TT.
Yes, sir.
Vulnerable time for slotted ALOHA is transmission time, and it is what? Exactly half of your pure ALOHA. Write it, and it that is exactly half of pure ALOHA. Okay. Reason, I think everybody have got it, so I'm not explaining the reason and so on. You have got the point. Okay. And what will be throughput here? Let me tell you that thing also. Take snapshot. I will jump to the next slide.
Done, sir.
Okay, so what was the throughput there? G into e ka power minus 2g. That was for pure ALOHA. But for slotted ALOHA, it is G into e ka power minus g. This is for slotted ALOHA. Okay, so here minus 2g and here minus g. Okay, so same numerical we can solve here also. Let me copy that thing. Yeah, so what should we do? I should copy this slide, na? No, actually I cannot copy it because screen sharing will go on if I do some experiments. So okay, so shortly I will write here. Okay, so S is G into e ka power minus g slotted ALOHA. That is the your throughput. Okay, and let me write it. Packet size is same numerical 200 bits. Bandwidth is 200 kbps. Okay, and network is generating 1000 frames per second. Okay, and second is 500 frames per second, and 250 frames per second. Same question I'm doing. Okay, 250 frames per second. Okay, and now we want to calculate the throughput. So same, I think I should not waste time here. So what will be the G value? G value for this will be, so in 1 second 1000 frames. So in 1 millisecond Only one frame. Why 1 millisecond? Because transmission time is coming to be 200 upon 200 into 10 to the power 3, that is 1 millisecond. Transmission time is 1 millisecond, so G is coming to be 1 for the first case. Okay, and when we see the throughput, it comes out to be 1 into e power minus 1, that is 1 upon e into 100, so approximately 36.8%. 36.8%. Okay, and these are, please, I should not waste time here, this is homework for you, you can calculate yourself. I have solved this because of a reason that throughput will be maximum for maximum throughput for slotted ALOHA is 36.8%, just double, because vulnerable time is just half, so obviously throughput will be doubled. Here there it was 18.4 and here it is 36.8. You should have to remember this figure. Take snapshot. I will jump to the next slide and I will write it properly in the next slide. Take snapshot.
Done, sir.
Okay, so maximum throughput of slotted ALOHA is maximum throughput of slotted ALOHA is 36.8%. Okay, approx 36.8% approx. Okay, yeah, so it is exactly double that of pure ALOHA, but pure ALOHA 18.4%. Okay, yeah, that's it. So this is all about slotted ALOHA. Very few questions have been asked. I have completed this topic. So now we are jumping to the next topic, that is CSMA. Take snapshot. I will jump to the next slide.
Done, sir.
Okay. So next topic is CSMA. CSMA is Carrier Sense Multiple Access. Carrier Sense Multiple Access. Okay, CSMA is Carrier Sense Multiple Access. So what this technique is saying, that is, I think I have told you in the previous lecture also, real life example, that we have a service lane and here is the highway. You want to take car from service lane to the highway. So what is your obvious thing? You will see left and right, you will say no car is coming, only then you will put your car onto the highway. So that directly this means you are sensing the highway, and after sensing it you are putting your car onto the highway. That is the basic scenario here. Carrier sense multiple access. That means a station will sense the carrier or sense the channel. If it finds that channel is busy, it will not send the data. If it finds channel to be idle or it is not busy, then it will send the data. That is the basic meaning of CSMA, Carrier Sense Multiple Access. Okay, so obviously here chances of collision are negligible. Okay, or rather it is very less, or probability of collision is very less. I am saying very less, I am not saying zero, because even though you are very you can say very conscious and everybody loves his or her life, okay, but still there are accidents on the highways. Okay, it is not like that. Everybody is conscious, everybody is wise enough, and everybody sees left and right, and only then and they put the car onto the highway, but still there are accidents going on. So there are some chances, but it is negligible. Okay, so do not say that there is no collision. There are chances of collision. Don't worry, I will tell you all these things in subsequent slides. But the basic idea is that, see, so you can take the notes. First point is to minimize the chances of collision. To minimize the chances of collision, CSMA technique was developed. To minimize the chances of collision, CSMA technique was developed. So underline this, minimize the chances. I'm not saying zero chance, I'm saying minimize. To minimize the chances of collision, CSMA technique was developed. Okay, and it is based on, see, it is based on principle of, see, what we are doing exactly here. So first we are sensing the channel. Okay, let me give you the idea. So here station A is there. So what it will do, it will first sense the channel. If it finds the channel is busy, it will not send the data. otherwise it will send the data. So what does this mean? So it is based on principle of listen before you talk. Okay, it is not like he started talking blindly. It will first listen the channel, or it will sense the channel. If it is busy, it will not send. That means listen before you talk. That is the basic principle of CSMA. Okay, please write it. CSMA is based on principle of listen before you talk. Listen before you talk, or sense before transmit. Okay, first you will sense the channel and then you will transmit. So CSMA is based on principle of listen before you talk, or sense before transmit, or sense before transmit, or sense before you or sense before transmit. Okay, so now see this figure. I am drawing a very simple figure: A, B, C, and D. So now this type of question might be asked in gate. So I can say like this: if A and B are communicating, A and B are communicating, question is, can C and D communicate? You will say yes, obviously, because when A and B are communicating like this, C and D are communicating here. There is no common channel and so on. But no, it is not the case. Many of you might think that A and B can communicate, C and D can communicate. Okay, but when B and C are communicating, then A and D cannot communicate because there is a common channel here. But it is not like that. I have told you in the previous lectures also. So what stations are sending data? Data is bits, but bits cannot travel on wire. On wire only current can be transmitted. So bits are converted into signals. So we cannot stop signal that please go here or do not go there and so on. So when A is communicating with B, so A signal will go everywhere. We cannot stop. Signal will go everywhere. Okay, similarly when C is communicating with D, C current or C signal will go here also, everywhere it will go. So when A and B are communicating, C and D cannot communicate. Please write this line. When A and B are communicating, C and D cannot communicate.
Yes.
When A and B are communicating, then C and D cannot communicate. C and D cannot communicate. C and D cannot communicate. Okay, why? Why? Because when A and B are communicating, that means already there is communication going on between A and B. So A data or A signal is going everywhere. So C will sense the channel and it will find it busy. Hence, they will not communicate. So we have written what? When A and B are communicating, then C and D cannot communicate, because when A and B are communicating, then C and D cannot communicate because C will sense the channel. Because C will sense the channel and it will find it busy. Because C will sense the channel and it will find it busy. Okay, and it will find it busy. Okay, yes. So now let me answer this question. I have repeated many times that chances of collision are very less. Okay, so you might argue, sir, when why there are chances of collision, or when collision can happen? Let me tell you that thing. Take snapshot. I will jump to the next slide.
Done, sir.
Okay, so here we have a station A and here we have station B. So A and B are most widely placed station. There are many stations between A and B, but A and B are most widely placed station. Okay, so 1 bit delay between most widely placed station, that is TP, or propagation time. So propagation time is 1 bit delay. We already know, but 1 bit delay from 1 bit delay between most widely placed stations. Between most widely placed stations. Okay, TP is this. So now if I say A want to send message to some other station, I do not know, whatever way, A want to send some data. So A has started the sending data. So it's 1 bit. It will take some time to reach B. It will take some time. So it has reached just here. Okay, and at this time, if B tries to send the data, B will sense the channel to be idle. Why? Because when B is sensing here, till here only bit has come. Okay, and here now B has sensed the channel and it will find it to be idle. It will again start sending its data, and here collision will occur. Okay, so what is the range of time in which collision can take place? See, this is for sure. If first bit from A reaches B, and then B tries to sense the channel, it will find it busy. So now there is no worry at all. But what is the time for one bit to reach from A to B? That is TP time. So TP time is range of time in which collision can take place. So here vulnerable time is coming to be TP. Are you getting it? Vulnerable time is equal to propagation time, that is TP. So in ALOHA, vulnerable time was twice the transmission time in ALOHA.
Yes, sir.
Slotted ALOHA,
It
vulnerable
is.
time was transmission time, but in CSMA, vulnerable time is propagation time only. I think you have got it now. So uh, range of time in which collision can take place. So TP is the time in which collision can take place. Okay, so A has started sending data. So 1 bit delay will be TP, na. So 1 bit will take TP time to reach B. Okay, now in this duration, in this TP time duration, if B tries to sense the channel, it will find it idle and it can send the data. So obviously chances of collision are there. So vulnerable time is TP. But these chances are very less because TP time is very small. 1 bit delay is very small because we are transferring signal. At speed of light, we are transferring the data. Okay, so if A and B are most widely placed station and say they are at just at say 10 meters apart or 20 meters apart, so it will take negligible amount of time. So obviously probability of collision will be almost zero. Okay, because propagation time will be very less. Okay.
Yes, sir.
Yes. So you can take snapshot. I will jump to the next slide.
Done, sir.
Okay. So in CSMA, now we are jumping to the next subtopic, that is persistence method. Persistence method. Okay. So the what do you mean by persistence method? Persistence method means what should station do if it finds the channel busy. For example, see this station A is there. Okay, and station B is here. So now station A is already sending data to some other station. Now B will sense the channel and obviously it will find it busy. So now persistence method will tell us what should B do. What should B do if it finds the channel busy? He will say, sir, it's obvious, it has to wait. Okay, but how much time it will wait? That is given by persistence method. Okay, so there are three types of persistence method. One is one persistence. Next is non-persistence. And the last is P persistence. One persistence, non-persistence, P persistence. One persistence means very obvious. One persistence means if B senses the channel to be busy, it will keep on sensing the channel. And the moment it finds channel to be idle, it will immediately send the data. One persistence means station will keep on sensing the channel if it is busy, and as soon as it finds the channel idle, it will send the data. That is the basic meaning of one persistence. Okay, one persistence means it is a small kid or small baby, and when his demand is not fulfilled, he will keep on arguing with his parents. No, I want this, no, I want this, no, I want this. And the moment he or she get the space, he will immediately do the thing whichever he or she wants. It is just like a small baby. That is one persistence. Non-persistence is a mature child. What mature child will do? It will sense the channel. If it is busy, it will wait for some time. It will not keep on sensing the channel again and again. It will wait for some random amount of time. Okay, and then it will again sense the channel. If it is still busy, it will wait some more random amount of time, and so on like this. That is non-persistence. Okay, yes. So obviously collision pre-persistence, don't worry, I will tell you about it later, but first of all we should write these points, or we will take notes of these also. So one persistence means it will keep on sensing the channel. So what do you think, probability of collision is high in which one persistence or non-persistence? In one persistence, obviously chances of collision are high, because see, if B and C, here C is there, okay, C is also sensing, the channel and it is also finding it to be busy. B and C both will keep on sensing the channel. The moment A stops sending data, B and C both will sense the channel to be idle and they both will send the data immediately and collision will occur. So chances of collision are very high in one persistence method. But in non-persistence it is low. Why it is low? Because they will wait for random amount of time and this random amount of time might be different for B and C. Like B wait for 1 second, C wait for 2 seconds. So chances of collision are still there but it is less in non-persistence. But channel utilization will be very less in non-persistence. Why? Because they are waiting for random amount of time. Now A has already stopped sending data, B is waiting for 1 second, C is waiting for 2 seconds. Why they are waiting? Okay, why they are spending such a random amount of time? And because they both are waiting, channel is idle, nobody is sending data, so obviously utilization will be less. Channel utilization will be less in non-persistence, but in one persistence channel utilization will be high. Why? Because every channel will be not idle, na? Because the moment we find the channel idle, it will immediately send the data. Okay, and one persistence method is used in your Ethernet protocol, which we are going to study next. Ethernet protocol uses one persistence. This question has been asked in GATE. Okay, so CSMA one persistence method is used in Ethernet. Actually Ethernet uses CSMA CD. I will tell you about, I have not told you about CD, so we will study in the next slide only, but I'm just giving you information. Ethernet uses CSMA CD with one persistence method. Okay, that is important point. Okay, so please take some notes. So please write about one persistence. Station keep on sensing the channel. For one persistence, station keeps on sensing the channel. Station keeps on sensing the channel, and as soon as it finds the channel idle, and as soon as it finds the channel idle, it will send the frame immediately. It will send the frame immediately. Okay, so this thing I have told you. Station keep on sensing the channel, and as soon as it finds the channel idle, it will send the frame immediately. Okay, next point. What was our next point? Probability of collision are high here. Please write it. Probability of collision is high. Probability of collision is high. Okay, I'm not giving you the reason. This figure is enough to remember. Okay, A is sending the data, B and C both are sensing the channel and they both will find it is busy, and the moment A stops sending data, B and C will sense the channel idle and they both will send the data and collision will occur. Okay, I'm not dictating it. If you want me, then I can dictate it. Otherwise
No,
it's
no.
simple. Yeah, it's good. Yes. Okay, and please write it. Ethernet LAN uses. Ethernet LAN uses. Don't worry, what is Ethernet? I will tell you. But please write it. This point has been asked in GATE. Ethernet LAN uses CSMA CD with one persistence method. Ethernet LAN uses CSMA CD with one persistence method. With one persistence method. Okay. Yes. So now we will write about non-persistence. Non-persistence. Okay. So in this method, if station finds the channel busy, in this method, if station find the channel busy, it wait for random amount of time. It wait for random amount of time and then sends the channel again. It wait for random amount of time and then sends the channel again. If it again finds the channel busy, it again wait for random amount of time. If it again finds the channel busy, it again wait for random amount of time. Okay. But as soon as it finds the channel idle, it immediately send the frame. Okay. But as soon as it finds the channel idle, it immediately send the frame. Next point, channel utilization will be less. Channel utilization will be less because chances are there. Channel utilization is less because chances are there. Many stations are waiting for random amount of time. Chances are there that many stations are waiting for random amount of time and channel is still idle. And channel is still idle. Okay, channel is idle and still many stations are waiting for the random amount of time. Okay, that is the basic problem here in non-persistence. Okay, please let me know if anybody is facing any difficulty here.
Clear, sir. Understood, sir.
Okay, so the last is p persistence. Okay, what do you mean by p persistence? So p persistence method can be used only when time is divided into slots of greater than or equal to TP time. Why TP time? Because TP was the vulnerable time here. So time should be divided into slots of greater than or equal to TP time, just like slotted ALOHA. Okay, so here also time will be divided into slots of greater than or equal to TP time. Okay, and it uses advantages of both one persistence and non persistence. Okay, so like one persistence, channel utilization will be high. Okay, channel utilization will be high, and like non persistence, probability of collision is low. Probability of collision is low. Probability of collision low. Okay, so for example, we can take 0.1 persistence. P means probability P, na? Okay, so the moment it finds the channel idle, it will send the data with probability P. P persistence means the moment it finds the channel idle, it will send with probability P. But one persistence means the moment it finds the channel idle, it will send with probability 1. Probability 1 means it will obviously send the data. Probability 1 means it will obviously send the data. But probability P, like we can say 0.1 persistence method. Okay, probability P. P can be either 0.1. For example, I say 0.1 persistence. So 0.1 persistence means 1 out of 10 slots. In 10 slots, from the 10 slots, it will send data in one of the slot. Okay, that is the basic meaning of P persistence. And what is the slot value? TP time. Okay, so I'm not going into detail. It is very mathematical thing. I am just giving you the idea. So you should know this thing, that P persistence is one of the best method, or you can say one of the best persistence method is P persistence, because it will it is having high channel utilization just like one persistence, and probability of collision is also low just like non persistence. So it is using advantages of both one persistence also as well as non persistence also. Okay, and in one persistence, the moment it finds the channel idle, it will send the data at probability 1, but here it will send the data at probability P. But that is the basic difference. So please take the notes. P persistence method can be used. First point was what? When time is divided into slots of TP time. So write it. P persistence method can be used if we have time slots. If we have time slots equal to or greater than TP time. If we have time slots, if we have time slots of equal to or greater than TP time. TP is propagation time. Okay, next point, it uses advantages of both one persistence and non persistence method. It uses advantages of both one persistence and non persistence method. That is it reduces the chances of collision and improve efficiency. That is, it reduces the chances of collision. It reduces the chances of collision and improves efficiency. And improve efficiency. Okay, hence it is best persistence method. Hence it is best persistence method. Okay, and you can take this also. For example, 0.1 persistence means, for example, 0.1 persistence means 0.1 persistence means station will send data in 0.1 persistence means station will send data in 1 out of 10 empty slots. Station will send data in 1 out of 10 empty slots. 1 out of 10 empty slots.
Yes, sir.
Okay, so this is all about CSMA. Now our CSMA protocol is over. So now you might say, sir, what if collision occur? So that means CSMA is not talking about what to do after collision. Okay, it is just talking about what if channel finds channel what if station finds channel busy, or station finds channel idle, and so on. It is talking about that. And basic idea it has given that you have to sense the channel, and after sensing you have to transmit. Okay, that means sense before you transmit. The basic idea is here, that is CSMA is over. But CSMA is not talking about what to do after collision. What if station A and B started sending data at the same time and collision occur? What to do after that? It is not talking about that. That means CSMA is not a complete protocol. It is incomplete protocol. So now we need to extend this, and we have two extensions of CSMA. Take snapshot of this.
Done, sir.
Okay, so now there are two extensions of CSMA. There are two extensions of CSMA, CSMA CD and CSMA CA. Okay, so please write this point. CSMA is incomplete protocol. CSMA is incomplete protocol because it does not give information about. CSMA is incomplete protocol because it does not give information about what to do after collision. Because it is not giving information about what to do after collision. What to do after collision. Okay, hence we have two extensions of CSMA. Hence we have two extensions of CSMA. One is CSMA CD and another is CSMA CA. CSMA CD and CSMA CA. Okay. So first we are going to explain CSMA CD. CD means collision detection. Collision detection. Many numericals have been asked from this topic, so this is important. CSMA CD is very important. Many numericals have been asked. Okay, so what do you mean by collision detection here? So obviously collisions can be detected here. That's why we are calling it as collision detection. So CSMA CD means carrier sense multiplexes with collision detection. With collision detection, and it is what extension of CSMA only. Why we need extension? Because CSMA is not talking about collisions. So we have to talk about collisions also. So CSMA CD is collision detection. CSMA CA is collision avoidance. Collision avoidance. Okay, so we are talking about now collision detection. So we might think that station is sending data. It is sending data, and after sending data it will check for collision is there or not. But no, it is not like that. Okay, station will keep on sending data from the sending port, and it will keep on listening for the collision from the listening port. So each station is having two ports, sending port and listening port. From sending port it is sending the data or signals, and from the listening port it is listening the collision. Okay, so if collision is detected, it will immediately stop sending data and so on. We will talk about it later, but the basic thing is that in CSMA CD, do not think that station will send data and then it will wait for collision and so on. No, it is not like that. Simultaneously it is doing both the tasks. That means it is sending data also and it is listening for collision also. So each station is having two ports, sending port and listening port. So please take the notes. In CSMA CD, station does not check for collision after transmission. In CSMA CD, station does not check for collision after transmission. In CSMA CD, station does not check for collision after transmission. Rather, it keep on sending frame. It keep on sending frame and simultaneously check for collision. Rather, it keep on sending frame and simultaneously check for collision. and simultaneously check for collision. So now question is how it will do both the things simultaneously. So for that it has two different ports, one for sending and one for listening. Next point, right? That means sender need two different ports. Sender need two different ports, one for sending data and another for detecting collision. One for sending data and another for detecting collision. One for sending data and other for detecting collision. Okay, so now what will happen? See, if station is sending data from the sending port and simultaneously it is listening for collision, what if it has detected collision? Okay, don't worry, I will tell you about how collision is detected and so on later, but let us assume that listening port has detected some collision. What should be done now? So obviously station one will immediately stop sending data. Now it will immediately stop because collision has occurred, so it will immediately stop sending data and it will send a special jam signal informing about collision to other stations also. It will send a jam signal. That means there is a traffic jam like this. That's why they are saying it as jamming signal. Okay, so jam signal means there is a traffic jam or there is a collision. So it will send jam signal to all the station informing about collision. Okay, so indirectly it is saying that there is a traffic jam here, so do not send data. Okay, it's just warning kind of thing. So you can write down, if collision is detected, then sender immediately stop sending frame. If collision is detected, then sender will immediately stop sending frame. Sender will immediately stop sending frame and it send jam signal informing about collision to each station. If collision is detected, then sender immediately stops sending frame and it sends jam signal informing about collision to each station. Informing about collision to each station. Okay, why I am dictating here notes? Because these are very important points. MSQs are coming now, and in MSQ they can ask such question. In CSMA CD, what station will do if it detect the collision? So it will immediately stop sending data and it will send jam signal informing about collision to each and every station. Okay, and how collision is detected, I will tell you about that thing also, don't worry. And they can ask this question, each station is having two different port, sending port and listening port. From sending port it is sending data and from listening port it is listening the collision. Okay, or it is detecting the collision, like that. Okay, so they can ask, and they can ask this question also, like sender will send the frame and then it will detect the collision, or it is simultaneously detecting the collision. No, it is simultaneously detecting the collision. It is sending data and simultaneously it is detecting collision also. Okay, so that's why I have dictated the notes, because these are very important point. Okay, now you can take snapshot of this. I will jump to the next slide.
Done, sir.
Okay, so now there are three obvious observations. There are three obvious observations which we have come across, the things which we have studied till now. From that we can take three obvious observations. Okay, so the very first observation is, see, if there is no collision detected by sender, then what sender will think? That receiver has received the frame fit and fine. Since receiver has received frame fit and fine, so and sender has come to know this. Now how sender has come to know this? Because no collision is detected, so there is no need of acknowledgement from receiver. So that is very important point. In CSMA there is no need of acknowledgement, but I have told in ALOHA there was need of acknowledgement. Why? Because there was no guarantee that sender has if sender has sent the frame, receiver has received it or not, because there was no collision detection and so there was nothing. Okay, and whenever station has data to send, it can send it immediately onto the link. Collision chances are very high. That's why sender was not, you can say, it was not guaranteed that receiver has received the frame. So sender rely on acknowledgements. Okay, so sender should wait for acknowledgement. And how much time it has to wait? 2 TP time. I had told you, no, that was round trip time and so on. Anyway, I'm not going into details of ALOHA. I have told you in the previous lecture itself. So I'm just considering here that there is no need of acknowledgements. Why? Because if sender has not detected collision, then it will assume that receiver has received the frame. Okay, now you might argue with me, sir, what if signal was corrupted, or some bits are not in order, and so on, some error has occurred, then what, then how sender will come to know? Okay, so this is not the task of your MAC layer. Okay, see, I have told you na, data link layer, IEEE has divided data link layer into two parts, LLC and MAC. Okay, so this is not the duty of MAC, this is the duty of LLC. I have told you na, error detection, error control, flow control, framing, three tasks are done by LLC. Are you getting it? Framing, error control, flow control. So flow control, error control, we have studied, go back and selective repeat and so on, everything we have studied. So LLC will handle all these tasks. It is not the responsibility of MAC. MAC will say, I have transferred the frame, this is my duty, I have done it, that's it. Now LLC will take care whether there was error or not and so on. So at LLC level, we can have acknowledgements. Of course we will have acknowledgements, because I have told you, for stop and wait, one acknowledgement. Okay, for each and every frame, that was individual acknowledgements. For go back and one cumulative acknowledgement. For selective repeat, individual acknowledgements. I have told you acknowledgements were there at LLC level. For at LLC level there will be acknowledgement, but at MAC level there will be no acknowledgements. I think you have got the point. Any doubt here?
No, sir. Understood, sir.
Okay, so every layer has different functionality. Okay, so no layer is interfering with the functionality of other layer. Okay, so that is the basic meaning of layered approach. Na, every layer is doing some fixed task. Okay, and no other and one layer is not interfering with the work of other layers. Okay, just like a big company. Okay, so employees are doing their task. No employee will interfere with other employee task. If they keep on interfering, then company will never run. That is the basic idea here. So we have layers, and every layer has different tasks. That's it. Okay, so do not say what if error occurred and so on. If error occurred, that will be taken care by LLC. It is not the responsibility of MAC. We are studying MAC. Okay, yes. So yeah, first observation, please write it. There is no need of ACK. There is no need of ACK, because if collision is not detected, there is no need of ACK, because if collision is not detected, then frame is definitely received by receiver. Okay, then frame is definitely received by receiver. There is no need of ACK, because if collision is not detected, then frame is definitely received by receiver. Okay, next important point. Next important point is, see this, since station is sending data as well as it is simultaneously listening for the collision. So if station has completely sent the frame and no collision is detected, then obviously receiver has received the frame. So there is no need to maintain copy of frame. Copy of frame, maintaining copy means after sending the frame, still station 1 is holding a copy of the frame or duplicate copy of the frame, so that if that frame is lost in the medium or something like or some error has occurred, it can send the frame again. But there is no need of such kind of things here, because if frame has been sent successfully and there is no collision, no problem at all. Okay, so no copy of frame is maintained. Okay, so please write it. Station does not maintain copy of frame at MAC layer. No copy. Station does not maintain copy of frame at MAC layer. Station does not maintain copy of frame at MAC layer because station simultaneously sending frame as well as detecting collision. Because station is simultaneously sending frame and detecting collision. Right, like this, because station is simultaneously sending frame and detecting collision. Okay, that's why. Okay, so copy is not maintained. Okay, next, third important point. Third important point is there should be a minimum duration of frame. Okay, let me tell you that thing. For example, see this. This is sender and this is receiver. This is the medium. Now, chances are there that sender has started sending data. Okay, and just before receiver here collision occurred. Why? Because receivers also try to send data, or some other station tries to send data, whatever may be the case. So just here collision has occurred. So here, since collision has occurred, so till here to here, what is the TP? What is this time? TP time. Now listening port, at listening port, this is your listening port. Now this after collision, signal will come back again at sender na, at listening port, it will be detected. So TP time for going and TP time for coming. So directly and indirectly 2 TP time. Okay, so station must send frame for at least 2 TP time, because it is, if it is not sending frame even for for less than 2 TP time, then chances are there that entire frame has gone from the sender. Okay, and after leaving after frame leaves the sender, collision occurred and listening port has detected the collision. But what is the use if listening port has detected the collision? Because already frame transmission has been completed by sender, and in the second point already I have told you it has not maintained any copy of the frame. Now since it has not maintained the copy, so how sender will retrieve the frame back? That is not at all possible. Okay, so basic idea is that sender should send frame for at least 2 TP time, because at the end, if a collision occurred, then TP time will be needed to reach at this end, and TP time again needed to reach this signal back towards sender, so that listening port can listen it. Okay, so the basic idea is for 2 TP time, station must send data, or station must send frame. Okay, that is the minimum duration, and on this part numerical has been asked. So please let me know if anybody is facing any difficulty in this third point.
No, sir.
Okay, so please write it. Minimum frame duration, MFD. Minimum frame duration must be 2 TP. Minimum frame duration must be 2 TP. Must be 2 TP. Okay, you can write shortly. This is because first bit from sender take TP time. This is because first bit from sender takes TP time to reach the receiver. This is because first bit from sender take TP time to reach the receiver. Okay, in 1 TP time it will reach the receiver, and the effect of collision take another TP time to reach the sender. Okay, and the effect of collision take another TP time to reach the sender. Take another TP time to reach the sender. Okay, so now what is the basic requirement? Sender should send frame for at least 2 TP time, because if frame has left the sender, or station has, or sender has completed transmission of the frame, and after that if collision is detected, now how sender will retrieve the frame back, because it has not maintained any copy. That is the basic principle. Okay, so write this point in a very shortcut manner. Hence the requirement is that sender must still be transmitting the frame after 2 TP time. Hence the requirement is that sender must still be transmitting the frame after 2 TP time. After 2 TP time. Okay, so now see this, how gate has asked question. So minimum frame duration should be 2 TP na. So what is the transmission time? We have studied transmission time is message size upon bandwidth. Now transmission time, what I am saying is station must send data for at least 2 TP time na? So transmission time should be at least 2 TP. So 2 into TP, that is equal to message size upon bandwidth. So message size comes out to be 2 TP multiplied by bandwidth. So they will ask this question, what should be the minimum frame size in CSMA CD? Okay, what should be the minimum frame size in CSMA CD? So minimum frame size should be, or message size should be 2 into TP into bandwidth. Why I am calling it as minimum frame size? Minimum frame size, why I am calling it? Because transmission time should be at least 2 TP, because minimum TT should be 2 TP. because minimum TT is 2 TP, so we will get minimum frame size. Okay, so minimum frame size should be 2 TP into bandwidth. On this formula, question have been asked in GATE. Okay, direct question have been asked. This is the advantage. Direct question. Okay, they will give you TP, they will give you bandwidth, and they will say minimum frame size for CSMA CD. Okay, so minimum frame size will be 2 into TP into bandwidth. So take some numerical, take snapshot. I will jump to the next slide.
Done, sir.
Okay, so write a numerical. Okay, let me write it here. A network uses CSMA CD. Okay, write the language also. Otherwise, you might get confused. A network uses CSMA CD. Write like this: CSMA slash CD. Like this. A network uses CSMA CD with bandwidth of 10 Mbps. With bandwidth of 10 Mbps. If round trip time is 51.2 microsecond, if round trip time is 51.2 microsecond, what is the minimum frame size? This is GATE question. Minimum frame size they are asking. So simply apply the formula. Minimum frame size, that will be equal to 2 into TP multiplied by bandwidth. Now 2 into, see this, now they have given RTT to be 51.2. So RTT is nothing but 2 into TP. So no need to worry. So directly write it. 51.2 microsecond means 10 to the power minus 6. Bandwidth is 10 Mbps. 10 into 10 to the power 6. This and this gone. 512 bytes or bits 512 bits. Mbps now bits per second. So you have to be very careful about units. 512 bits is my answer. Now they can give you option like 64 bytes. So 512 bits is nothing but 64 bytes. You can check it out. Divide by 8. Divide by 8 means 512 is 2 power 9. Divide by 8 is 2 power 3. 2 power 6. 2 power 6 is nothing but 64. So 64 bytes might be the option. So do not get confused. We are not having 512 bits as our 512 is not the answer. So see the units. 512 bits is my answer. So they can give 64 bytes as answer. They will also say 512 bytes. Do not get confused. See this. If you want me that I should make the option, I will make option like this. 512 bytes. 64 bytes. 512 bits. 64 bits. MSQ type of question they can ask. We'll say 512 bits or 64 bytes. B and C. Both are correct. Okay.
Yes, sir.
Yeah. Okay. So take snapshot. I will jump to the next slide.
Done, sir.
So now I have told you that minimum frame size should be 64 bytes. Now what if station is not having 64 bytes data? If it want to send a small frame, then what should be done? For example, if station want to send 32 byte frame, then what will happen? Station want to send 32 byte frame, but minimum frame size is 64 bytes. What should be done now? So now station will send 32 byte garbage data. Station will send 32 byte garbage data. So 32 plus 32, that is equal to 64 byte frame will be sent. So requirement is that you have to send 64 byte frame. So what if you do not have 64 byte? So what station will do? For example, if station want to send 32 byte frame, then what it will do? Station will send 32 byte garbage data. So 32 plus 32, that is 64 byte frame it will send. Okay. So we call it as byte stuffing. Okay. So 32 byte garbage data it is sending. So this is known as byte stuffing. Byte stuffing it has to do. Okay. So we eat stuffed parantha and so on. That is just like that only. Stuffed parantha means what? We have done some stuffing. So that is done here also. 32 byte data and then 32 byte stuffing is done here. So that in order to make 64 byte frame, it can be sent onto the channel. Okay, that is the basic idea here. Yeah, so you can take snapshot. I will jump to the next slide.
Done, sir.
Okay, so now we have almost completed this protocol, but you might say, sir, you didn't tell about how to detect the collision and so on. So let me tell you that briefly. So there are three types of signal level. There are three type of signal level. One is zero level. Zero level means channel is idle. Channel is idle. Next is normal level. Normal level means you can say station is sending data normally. Okay, that means one of the station has successfully captured the channel. We should say like this. Technically, we should say one of the station has successfully captured the channel. Has successfully captured the channel. Okay, that means it is successfully sending data. Why I have used the word capture the channel? See this. So if station A wants to send data, it will send first. It will send data onto the link. Okay, so it will take some time. So how much time it will take? TP time. So I will say after TP time is over, there is no collision at all. Why? Because now station A has successfully captured the channel. That means now after TP time, every station will sense the channel and it will find it to be busy. So no station will send data. Are you getting it? Because now they will find the channel to be busy. And since they are finding channel to be busy, so what indirectly I will say? A has successfully captured the channel. That's why I have used that one of the station has successfully captured the channel. That is the basic meaning of normal level. Okay, and the last is abnormal level. Abnormal level. Abnormal level means collision has occurred. Collision occurred. Abnormal level means strength of signal is doubled. Strength of signal is doubled. Okay, strength is exactly doubled. Okay, so I think you have got it now. When see, signal is like this, another signal is coming like this. So when they will collide, how signal will become? It will become double strength. Okay, that is the basic meaning of abnormal level. So there are three levels of signal. So why we have studied this? I am saying how to detect collision. How to detect collision. So for this, what we will say, abnormal level. So at listening port, if sender sends the channel as abnormal, if station sends abnormal level, it will say collision has occurred. And if collision is there, then what it will do? It will stop sending data and it will send a jamming signal informing about you can say collision to all the stations. Okay. Yes, so you can take snapshot of this. I will jump to the next slide, and in the next slide I will tell you about this basic diagram of this. Okay, so we will do flow chart of this. Take snapshot.
Done, sir.
Okay. Yes, so we will say start. So attempt will be 0. A is equal to 0. Apply one of the persistence method. Whatever method you want you can use, like one persistence, p persistence, non persistence, whatever method you want you can take. Okay, so next is transmission done or collision detected. Transmission done or collision detected. Okay, so no means both are false. Transmission is not done and collision is not detected. Then what you will do? You will keep on transmitting the data and receiving data. That means receiving signal means you are detecting the collision. So transmit and receive, transmit and receive. You will keep on doing like this. So let me write it. So you will say transmit and receive. Transmit and receive. This is a loop. So transmission done or collision detected? No, then transmit and receive. Transmit and receive. Okay, so you are doing like that. Okay, transmit and receive. Okay, so now if transmission done or collision detected, something has been done. That means yes. If yes is there, then we will say now there are two chances now. Whether you have done the transmission or collision has detected, I do not know. Yes means what? Either this is true or this is true. Okay, so for the then I have to check again. So we will check collision detected. Collision detected. Okay, if collision is not detected, no, then we will say success. Why we have got success? Because collision is not detected, that means transmission has been done. If transmission has been done, then we have got the success. Okay, so now what if collision has been detected? What if collision has been detected? So what should we say now? So actually I, actually my we should draw it here. Okay, yes, so collision detected, no. Then if collision is detected, yes, then what should we do? Send jam signal. Send jam signal. Why this signal, jam signal is sent? It will inform every station that collision has occurred, so please do not send data. K is equal to k plus 1. So it's just like that only, just like ALOHA. Zeroth attempt, then attempt will keep on increasing and so on. So k greater than k max, about. K greater than k max. If yes, then abort the transmission. No, then choose a random number r between. Choose a random number r between 0 and 2 power k minus 1. Choose a random number r. Choose a random number r between 0 and 2 power k minus 1. Okay, and then wait for RTT time. Wait for r into RTT time. Okay, it will wait for r into RTT time. Okay, yes, and then it will say it will apply one of the persistence method and so on. It will keep on doing this. This RTT is what? Round trip time. Okay, RTT is generally round trip time. Let me write it, round trip time. Okay, yes, take the snapshot. I will jump to the next slide now.
Thanks, sir.
Okay, yes. So now we are going to start efficiency of Okay, I think screen sharing has gone. I have got this. Screen has been freeze now.
Cursor is not moving, sir. Do try moving it, sir.
Yeah, I am writing something.
Nice, sir.
Nothing. No? I have got the sound, the famous sound of click. Let me check the reason. What has happened? Just give me 1 or 2 minutes. What has happened? I don't know why it happens with me only.
Hmm.
Let me check. Hmm. Yes. I hope it is visible now.
Sir.
Okay. So that's it. This is all about your CSMA CD. Now we are going to start CSMA CA. Okay. So CSMA CA. CA
Not
means
able to see anything. Once again, I think it's lost.
okay. Now it's visible.
Yes, sir.
Ah. So next is CSMA CA. CA is collision avoidance. CA is collision avoidance. Okay. So CSMA CD actually work for wired lens. CSMA CD works for wired lens. Why? Because if collision is there, see, sender has sent the data to the receiver. At this point, collision occurred. So now strength will be doubled. Signal strength will be doubled, and it will go back, and listening port of the sender will detect the collision. So basically, in wire, attenuation is very less. New word I am introducing: attenuation. Let me write it properly. Attenuation. Attenuation means loss in strength of signal. Loss in strength of signal. For example, you have sent signal with this strength. Slowly it will keep on decreasing like this. This is attenuation. Attenuation means loss in strength of signal. So in wired media, attenuation is very less. Okay, in wired media, in wired media, attenuation is less. Why it is less? Because resistance is very less in wired media. Okay, but in wireless media, attenuation is very high. Okay, so that means directly and indirectly I want to say that if sender has sent the signal and here's a collision has occurred and signal go back, so the listening port will detect a double strength signal. Okay, it is able to detect double strength signal. But if it is wireless media, attenuation is very high. That means from sender, if you send the data in wireless media, then till it reaches receiver, it it will be having only 5% of its original strength. Okay, so if the sender has sent data with some x amount of strength, then the moment or till it reaches receiver, it will remain only its 5% strength. Now even if collision occur, then how receiver will detect it? That is next to impossible, because receiver will not receive that signal again. So collision detection will not work in wireless media because attenuation is very high. Okay, so in that scenario we have to use collision avoidance. That means we will try to avoid the collision. That means we will do some basic tasks with the help of which we can avoid collision. Okay, that is CA. So please write this point.
Okay.
CSMA CD is used in wired networks. CSMA CD is used in wired networks because received signal has almost same strength as the sent signal. CSMA CD is used in wired networks because received signal has almost same strength as sent signal. Okay, the receiver has received the signal with some strength that is same as which it was sent. Okay, so sent and received signal both have almost same strength. That means attenuation is very less. So what we have written, CSMA CD is used in wired networks because the received signal has almost same strength as sent signal because attenuation is less. Because attenuation is less. Because attenuation is less. Okay. So this
Yes, sir.
means this means in a collision, this means in a collision the detected strength is almost doubled. This means in a collision the detected strength is almost doubled. Almost doubled. Okay, but in wireless network what is the main problem? It will remain only 5%. So the difference in strength is very high. Strength of the signal which sender has sent and the strength of signal which receiver has received, that is almost 5% only. Okay, so very high attenuation. Okay, so even if collision is detected, even if collision occurs, sender will never be able to detect it. That is the basic problem. So please write it. However, in wireless network, however, in wireless network, attenuation is very high. However, in wireless network, attenuation is very high. So, so sender is not able to detect the collision. So sender will not be able to detect the collision. Sender will not be able to detect the collision. Okay, hence another method was developed. Hence another method was developed called CSMA-CA. Hence another method was developed called CSMA-CA. Okay, CA is collision avoidance. Collision avoidance. Okay, so now question arises, how we will avoid this collision? So to avoid this collision, we have three procedures. Let me tell you that thing. Take snapshot. I will jump to the next slide.
Done, sir.
Okay. So now question arises. Question is how to avoid collision. Okay, I think slides are over. So let me copy the slides. Yes. So the question is how to avoid collision. So for this we have three procedures. We have three procedures. First is interframe space. Second is contention window. And the third is acknowledgement. Interframe space time. We should say like this, interframe space time, IFS time. Shortly we will say IFS time. Contention window time. Shortly we will say CW time. And then acknowledgements. Okay. So there are three procedures. Okay. So the first is interframe space time. So let me tell you that thing. So see this, we have to avoid collision now. So for to avoid collision, sender should be extra careful. Okay, first take snapshot. I will jump to the next slide and there I will tell you about IFS time. Take snapshot.
Done, sir.
Okay, so first is IFS time. Now what we are saying is, since we have to avoid collision, sender must be extra careful. Now,
Hmm.
to avoid collision, sender must be extra careful. So what do you mean by extra careful? So let me tell you that thing. Say this. If we have a station B here who wants to send data. So now what it will do? It will it will not send data immediately. It will first wait for the time. See this. If we have a most widely placed station to the back of it, that is A. A is the most widely station which is back of it, which is back of B. Okay, and if station B wants to send data, it will wait for amount of time needed for the one bit to reach from station A to B. Now what B will assume? B will assume that I want to send data. Chances are there that A also want to send data at this time only. What B is thinking, that I want to send data, but chances are there that that A also want to send data at this time only. So it will wait for propagation time or one bit delay from this A to B. One bit delay from this A to B, and this time is known as IFS time. And by mistake I have told you that it is TP, but actually it is not propagation time. Propagation time is one bit delay between most widely placed station. For example, this is C, this is your LAN. So I will say from A to C, one bit delay, this is your TP. From A to B it is not TP. I'm just saying it is one bit delay from A to B. That's it. This is known as IFS time. So logic is very simple. Na? B want to send data, it will wait, it will say, okay, I want to send data, but I should not send it. I will wait for this for one bit delay for the most widely placed station. Okay, so the station which is very far away from A, and sorry, station which is very far away from B. B will think that A might also want to send data at the same time, so it will wait for one bit delay. Okay, that is IFS time. So please write it. What do you mean by IFS time? When an idle channel is found, when an idle channel is found, the station does not send frame immediately. When an idle channel is found, the station does not send frame immediately. The station does not send frame immediately. Rather, it waits for a period of time called IFS time. When when an idle channel is found, the station does not send frame immediately. Rather, it waits for a period of time called IFS time. Okay, it is not sending frame immediately. It will wait for a period of time called IFS time. So now I am telling you what is IFS time. See, write it. IFS is the time needed for a signal. IFS is the time needed for a signal. Is the time needed for a signal to reach the given station. To reach the given station from the station. From the station which is far behind the given station. From the station which is far behind the given station. Okay, that is IFS time. So IFS time is the time needed for a signal to reach the given station from the station which is far behind the given station. Okay, and why it is doing so? So it is assuming that if B want to send data, it will think that the station which is far behind me, it also want to send data at the same time only, so I should wait for one bit delay. That's it. This is IFS time. So I hope you have got it. So next is CW or contention window time. Take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is CW time. Contention window time. So contention window is nothing but it is the amount of here also we will divide the time into slots of transmission time. Okay, we will divide the time into slots of TT time, transmission time. Okay, divide time into slots of TT, that is transmission time. Okay, so after IFS time is over, even then station will not send data. It will take a random number R between 0 to 2 power k minus 1, where k is the number of attempt. Okay, it will choose a random number R between 0 to 2 power k minus 1, and it will wait for R empty slots. Empty slots means if it find at the beginning of the slot, if station sends the channel and it finds to be busy, it will not count that slot. For example, I will say it will wait for say two empty slots. Okay, and each slot is of one transmission time. Now after one transmission time, station will sense the channel. If it finds to be busy, it will not count that to be empty. Obviously it is not empty slot, so it will wait for the next slot. Next slot come, it find to be busy, it will not count it. Next slot, it find to be idle, it will count one slot, like this. So it will wait for two empty slots and then it will send the data. That is the basic meaning of CW time or contention window time. Okay, so please write it. Divide the time into slots of transmission time. Divide the time into slots of transmission time. Divide the time into slots of transmission time. Next, after IFS time, station does not send frame immediately. After IFS time, station does not send frame immediately. Rather, it chooses a random number of slots as its waiting time. Rather, it chooses a random number of slots as its waiting time. Rather, it chooses a random number of slots as its waiting time. It chooses a random number of slots as its waiting time. Okay, yes, and these next point, and these slots should be empty. These slots should be empty. These slots should be empty. Okay, and random number is between 0 to 2 power k minus 1. Random number is between 0 to 2 power k minus 1, where k is the number of attempt. Where k is the number of attempt. Okay, yes. So contention window time is over. First was IFS time, next was contention window time. So the last was acknowledgements, ACK. So now even after IFS time and contention window time, still there are some chances of collision. We have taken very good precaution. IFS time, okay, and then contention window time. Even after that also there are some chances of collision. So sender will wait for acknowledgement from receiver also. Okay, that is the basic meaning of acknowledgement. So here we have acknowledgements. In CSMA CD there was no acknowledgement. Let me write it. In ALOHA, whether it is slotted ALOHA or pure ALOHA, acknowledgements were there. Okay, ALOHA, pure or slotted. Pure or slotted, it hardly matters to me. Whatever may be the case, we have acknowledgements. Okay, then in CSMA is not a complete protocol, so I'm not talking about it. I will talk about CSMA CD or CSMA CA. In CSMA CD, there is no need of acknowledgements, but in CSMA CA, we have acknowledgements. Okay, these are very important points. They will ask in which protocol acknowledgements are needed, in which protocol acknowledgements are not needed. So except CSMA CD, every protocol need acknowledgement. Okay, yes. So please write it. With all these precautions, there are still chances of collision. With all these precautions, there are still chances of collision. With all these precautions, there are still chances of collision. Hence, a positive acknowledgement and timer. Hence, a positive acknowledgement and timer. Hence, a positive acknowledgement and timer help in guaranteeing that receiver has received the frame. Help in guaranteeing that receiver has received the frame. Receiver has received the frame. Okay, this will guarantee that Help in guarantee.
Yes, sir.
Okay, help in guarantee that receiver has received the frame. Okay, so this is all about your CSMA CA. So now everything is over. Now, okay, and one flow chart is remaining, but time is up. So in the next class, we will make the flow chart. Okay, and after that, we will start Ethernet protocol. And one more topic is left out. Yeah, efficiency of CSMA, efficiency of CSMA, efficiency of CSMA, and flow chart of CSMA CA, flow chart of CSMA CA. More precisely, we will talk about efficiency of CSMA CD. That is more important. Okay, so two things, two topics we are left out. After that, our you can say access control protocols are also over. So access control, I have told you na, we have three categories of protocol: random access, control access, and channelization. Random access we have completed now. Rather in the next class we will complete it, CSMA CA flowchart, and after efficiency of CSMA CD, random access is over. Then control access, there we were having a token passing and other protocols were there. They are not in GATE syllabus. And channelization, FDMA, TDMA, CDMA, they are also not in GATE syllabus. So more precisely, I want to say that your multiple access protocols will be over. Okay, and after that, so after these two small topics, we will jump to the very important protocol, that is Ethernet. Okay, what is Ethernet, why we want it, and so on. We will study from the basic, from the scratch itself. Okay, so Ethernet we will complete. Okay, and then slowly we will jump to the other topics also. Okay, if anybody is having any doubt, you can ask me. Otherwise, I will wind up the class here itself, and we will study this thing in the next class.
Yes, sir.
Okay, okay then. So good night. Bye bye.
Good night, sir. Thank you, sir.
Okay.